All right, 5.10. We'll do number 61. Let's see here. All right, 61 here. Okay. Refer to figure 32 on page, okay, both figures, 32, 33, which are there. All right, with an airplane loaded as follows, what action can be taken to balance the airplane? So this is, all right, center of gravity problem here. So let's write down what we need to know. We need to know the weight and the momentum. All right, so let's figure this out. We need to know well, we have the front seat. We have the rear seat. We have the main wing tanks. Main wing tanks. All right. Well, that's just, that's fuel, right? We'll call that fuel. And let's see here, and the empty weight of the vehicle, right? With oil. So now we just have to fill in the numbers. All right. So the front seat occupants are 411. That's fine. Rear seat is 100. That's great. Fuel, 44 gallons. No, that's not good. That's, we have to, that's 1 gallon. Yeah, we need to do our math. So 44, 44 times 6 equals 264. Great. So this will be 264. And the empty weight, let's see, is that given here in our, let's see where we can find that in our chart. Let's magnify this and magnify it some more. Okay, empty weight, empty weight. Usable times, oh, here we go. Empty weight, it's right here. 2015. All right, so that's great. I'll uncircle that. So we can write that data right here. (2015). Now we have to write the moment. Delete this. 215, and we know that the moment is is 1,554. Okay. Now fuel. Let's find out what the fuel is. The fuel, we have 264. 264 is not an option there. I'm not seeing that. So we have to multiply 264. So what do we multiply 264 by? Or is it on there? Let's see. Oh, it is. Here it is. Wait, 264 and 198. There we go. See that? Right here. 264, 198. So that makes our job a little bit easier. So we can put 198. Great. Let's go up. Rear seat. Rear seat is 100. Let's see, if that's the rear seat. Occupants, all right. Make that larger. Rear seat. Unfortunately, that is not given for the rear seat. So we have to multiply by 121 and divide by 100. Well, that's an easy equation, but already just for the sake of it. So you have 100 times 121 is the iron. And then we divide by 100 because that's what it says there, moment over 100. Right. And so you can cross that out. We're just left with 121 anyway. So that's going to be 121. Next, 411. That's for the front seat, and 411 is not there. So we have to multiply 411 by, if you look at it, we have to multiply by 85 over 100. Oops. $411 times 85 over 100. When we do the math, we have 411 times 85 equals 34,935. Move the decimal place, and we get 349.35. So 349.35. So 1, 2, 3, 4, 1, 2. We can tally up everything. This comes out to be 2,222.35. And this here becomes 2,790. All right, now that we have our sums, we have to figure out if we're within range, not within range, and so forth. So looking at the number 2,790, let's just focus on that. So are we good or not good? So if we look at our numbers here, we're at 2,790, and it is right here. So based on that, we are within minimum moment. We are good. Our number is 2, because our number is 2,000. Our moment is 2,222. So we are below 2,000. Hold on, I can't see so clearly. Let me check in my book. Yes, so we are below. We are good. We could even can add 100-pound weight to the baggage compartment. So we are good since we are below. That's the main thing. So we were to add 100. Our new loaded plane technically would be 2,890 is basically our max. But at 2,790, we are good. And the moment is 2,222. That falls below. So we are just, if we read about it, what we needed when we read on the page with the airplane loaded as follows: what action can be taken to balance the plane? Because we are below, we need to add 100 to get it to that point. Because we are at, well, here, let me explain. So this is at 2,222. 22. The minimum is so we're looking at that number 2,222. It falls between 2,000 to 200. It falls below 2,232 and 2,366. And our weight is 2,790. But so what it says is the maximum. If you look on the chart, it says minimum moments and maximum moments. So let me zoom the chart. So since we are below the minimum, actually, we need to add 100 to balance the plane. It says it right there. So that's why the answer for 61 is B. All right, 62. Determine if the airplane weight is balanced within limits. Same thing, we'll be looking at the moment limits versus weights to see if we're within balance. So we have our weight and our moments, right? So with front seat is 340, rear seat is 295, fuel, main wing tanks is 44 gallons. 44 gallons is not good. You have to multiply that by 6. So 44 times 6 equals 264. That's 264. And baggage is 56. Our empty weight with oil is 2,015. Now the moments of that is 1,554. All right, let's see if baggage is there. Looking at baggage on the chart. Oh no, unfortunately baggage is not given there. But let's see here. What can we do? Looks like we're gonna have to find the average between 50 and 60. So for 50, it's 70. I will magnify that. It's over here. For 50, it's 70. And for 60, it's 84. So let's find the average of those two. So you have 70 plus 84 divided by 2, and we get 77. Can we? Oh, I keep forgetting that we don't have to do interpolation. The number is given, right? Arm is 140. I forgot. So it's, what's the number they give? Once again, 56. So we have 56. We need to multiply that by 140 and divide by 100, and that will give us our answer. So we have 56 times 140, divide, move the decimal place, we get 78.4. All right, so 78.4. I keep forgetting that we can do that. So here in the book, they just give a whole number. So I will follow that. All right, next, our fuel. Our fuel is 264. Oh, we were given that 198. That's great. So, oops. It says it right here, 198. So we can put that there, 198. Our rear seat is 295. 295 is not given, but we can do our math. All right, and you see our arm is 121 for rear seat. So all we have to do is 295 times, we're doing 295 times 121 over 100. And that should give us our answer. So 295 times 121 equals that number divided by 100. And we get 356.95, and the book rounded off to 357. So, all right. So, all right, 357. Next number is 340. And 340 for our front seat. And the arm given here, since it's not in the text, is 85 over 100. So 340 times 85 divided by 100, 289. So now we have all the numbers we need. All we have to do is tally up. So we tally this up, we get 2,476. Tally this up, we get 2,970. Now let's look to see if we fall within the limit, or if we had to add any, weight, or if we're overweight and so forth. So here, what are they asking for? Determine the airplane weight is balanced, is within limits. All right, so first of all, we're 297, right? 2,900. So we are, oh boy. Here we go. 2,950 is the limit. So right there, if it's 2,950 and our current weight is 2,970, we are 20 pounds over. All right, so that's the first thing. So we're 20 pounds over. What about the center of gravity? Let's check that out. So to check our center of gravity, so at first you may think we're not within the limits. But if you look at the very last part, right? What does this say? It says 2,422 and 2,499. And our number is 2,477, which falls which falls within the parameters given. So we are within limits. So the answer is B, 20 pounds overweight, CG within limits. Kind of tricky. Okay, next is 63. So we have our weight and our moment. So our weight is, for our front seat, 350. For the rear seat, 325. For the baggage, 27. For fuel, we have 27. So we know we have to do 27 times 6. So 27 times 6 equals 162. I made a mistake writing things down. Baggage is fine. Fuel is 35, I'm sorry. So to do 35 times 6. 35 times 6 is 210. Yes, that sounds right. Okay, now the aircraft is 2015, and the moment is oops, 1,554. All right, now let's see if we can find these things there. So fuel. The fuel number we have is 210. 210 is there. Great, that's 158. It's right here, 158. So 158. All right, next is 27, which is for baggage. Baggage, let's see here. Is 27 a number? Nope, 27 is not there. I'm not going to do any averaging. I've been doing that by mistake quite often. So now we have to do the math. So we have to do, let's see here. Looking at the discussion to see if it's there, but I don't. But out of good faith, I know what I'm doing at this point. 27 times 140 and over 100. So 27 times 140. To move the decimal place, you get 30. The book is averaging 38. Okay, and that's no problem. Oops. 38. Okay. Next is 325 for the rear seat. Let's see here. Nope, we don't have that. That's all right. 325 for the rear seat. We're multiplying by 121. It says that right here, the rear seat is 121. And then for the front seat, when we get there, is 85. So we have to do 325 times 121 over 100. All right, when we do that, 325 times 121 equals that. Move the decimal place, 393. Okay, that's no problem. 393. Next is we have the next one, right? 350 at the front seat, and we said that's going to be multiplied by, oh, what do we say? 85. And that's also over 100. So 350 times 85 divided by 100 equals 290. Okay, they're rounding it up to 298. All right, now having that, all we have to do is tally. We get 2,441. And then for this, we get 2,927. Okay. So the question is asking, calculate the weight and balance. All right, we did that, the weight and the balance. We hadn't do the balance yet. If the CG and the weight of the airplane are within the limits. Well, let's take a look at it. So we're 2,927. All right, so I'll write that there. So the max load of the plane, landing takeoff, was 2,950. We are at 2,927. All right, so we are within limits there. So that's one positive, but they're not asking for that. All right, next thing. Is the CGG, is the center of gravity of the momentum within limits? Let's take a look at that, the last one. Let's see here, 2441. 244, well, we're at 2441, right? 2441. So looking at the chart, let me zoom it and focus on these. All right, so we're at 2,927. So it's, we can look at all these two. So we're in between these. So our number needs to be, we're at 2,441. That falls in between. It falls within that range. So we're good. But for now, we're not done yet. We need to figure out the CG. So we have to follow the CG formula, which I wrote in the previous examples. I'll make this big. So define CG. The formula is momentum over weight times 100. So our momentum is 2,441 over 2,927 times 100, and that gives us 83.4. 83.4 more or less. And that is B, so that is within limits. So our 2,441 was within limits. If you look at it, if you look at, we have a little mistake over here. So what we're looking at, okay, what we're looking at is this number, 2,930. There we go, because that's the closest number to us. And we're at 2,441, which falls in between more or less. So that means we're good to go within the momentum. So it's within limits. And then after doing the math, we got to 83.4 more or less. So the answer is B. Next problem is number 64. On what What is the maximum amount of baggage that can be carried when the airplane is loaded as follows? So, all right, we have our weight and we have our, okay, so our front seat is 327. Our rear seat, 293. Our fuel is 35 gallons. So we'll do 35 right off times 6. So that is 210. Baggage is what? Unknown. And we need the empty weight with oil. And that's given at 2015. Now we just have to find the moment of each one. So we know this is at 1,554. I'll come back to the other one. All right. So 327 for front seat. That is not given, but we know what we need to do. So we know that's 327. We multiply that by the arm for the front seat, which is given at 85. So that's 27, whatever, divide over 100. And that gives us 275. I believe I made a mistake somewhere. Oh, the front seat is 387. That doesn't look nice. 387. All right. Back to what I was doing. So 387 times the arm, which is 85. Okay, over 100 with the decimal place is 328.95. So 329. Okay, we're good. Next, we have 293. Right, that's the rear seat. 293 is not there. We multiply that by 121. Great, divided by 100. We get 354.5 or 355. All right, fuel. Let's see here. Is fuel given? Fuel is given. Fuel is given. We have 158 for the fuel. All right, baggage. What do we do for baggage? Well, we have to do, I believe, a few steps. No problem. So let's worry about baggage. We're not really worried about the moments. So we have to find the baggage. Well, after we add everything together, we get 2,905. But the max weight we can carry is 2,950. Just if you're doubting, it says that here, and it says that here. So all we have to do is subtract that number. from that. So if we subtract 2,950 from this, right, and take the absolute value of it, we get 45. So that is the answer A. This will equal 45. All right, so that takes care of that. So we need to find the CG for 65, number 65. CG is important. So the CG formula is momentum. I'll write this way, momentum over weight, right? And if needed, depending, sometimes you need to multiply the 1,000, but depending on what we're working with. All right, so keeping that in mind, let's continue on. All right. So upon landing, the front passenger weighs 180 pounds. And we're working with momentum. So I write here, the passenger, rear passenger, right, weighs 180 pounds. All right. From the front passenger, 180 pounds, departs the plane. A rear passenger, front passenger, 180 pounds. Rear passenger, 240 pounds. Moves to the front passenger position. Oh, okay. What effect does this have on the CG if the airplane weighed 2,690 pounds and the momentum was, they already did the 100 for us. Okay, it was 2,260 just prior to the passenger transfer. So, all right. So this has two problems. So you have the old CG. Maybe I'll move these numbers over here. So you have the old, and then you have the new. All right. So let's figure this out. We don't have to look at the chart for this one, I believe. And they tell us, okay, so reading again, a rear passenger moves to the front passenger position. What effect does this have on the CG if the airplane weighed 2,690 pounds? So the airplane did, so that'll be old, did weigh 2,690 pounds. All right, it did indeed weigh that. And that's the first thing. And the momentum was 2,260. All right, 2,260. Now, the number that's given was divided. So we don't want to use the momentum over 100. All right, so we want the full number. So we want to restore that. So multiply 2,260. So you add your 2 zeros, and then you get the original number. All right, because it was already divided. So that would be 2, 6, and then add my 2 other zeros. 2, 2, right? 3. Am I right? Hold on. No, I had to add my 2 zeros. There you go. So that's the old setup. That's the first thing. Now let's figure out the new setup. So the new setup, there's a difference that's happening here. So we have the two different weights, but in order to work with those weights, all right, so let's set up our new equation. Let's take the denominator. So what's happening is we're losing 180 pounds in the denominator because the passenger from the front seat, right? Because what's happening here, the front passenger upon landing, the front passenger departs the airplane and the rear passenger moves to the front passenger position. So now we're without that 180 pounds. That person is no longer in the plane. So the plane no longer weighs 2,690 pounds. We're 180 pounds lighter. So when we subtract 2,690 pounds from 180, we're left with 2,510 pounds. All right, what else changes? The number in the top, the numerator also changes. So to find the numerator, we have to work with since the front seat person is gone, we need to work with the rear seat. We need to find the moment for when it was the front, and the moment for rear, and then the difference between those will give us an idea what's happening here. So looking at the chart, for the front is 85. Just to double check, yes, for the front seat is 85 right here, and for the rear seat is 121. All right, so keeping that in mind, we can do the math over here. Okay, and we're working with the number 204. All right, so 204, we'll do the front seat. 204 times 85 over 100 gives us 173. So this is 173. Now for the front, for the rear. Rear is more, I believe. Now we have 204 times 121 divided by 100, and we get 246 point something, so we'll say 247. So we subtract these from each other and get the absolute value of that. And the absolute yes, I believe we subtract. Is 74. So this 74 is when the 204-pound passenger from the rear seat, when he moves to the front, this reduces the moment over 100 by approximately 74. So now the total reduction needs to be recalculated and adjusted to give us the proper answer. To be adjusted, we also need to, so this takes care of this block, all right? We understand what's transpiring there. And you also need to find the moments for this patient, this passenger. So we have 180, now it's the front seat. 180, and that number is given to us. that moment is 100 and what is it on the board? It says 153. Okay, that is 153. So now we have our two numbers. We have 153 and 74. So now to see how much change has happened, we need to add those two numbers together. So we have 153 plus 74. 153 plus 74 gives us 227. So 227 needs to be subtracted from, and it needs to be subtracted from the moments over 100 initially. So whatever the numerator was, whatever this numerator was, it needs to be subtracted from that, right? Not taken into account prior to the multiplying of 100, right? So you would subtract it from that. Does it make sense? So when you subtract it from that, you will get 2033. Then you need to add your two zeros, and that is your new central. That's your new CG. So now we have to find the quotient for this and the quotient for this, and then subtract them from each other, and then we should have our answers. So after doing the math for that, we get 84.01. This we receive 81.00. So if we were, so that means there is a 3-inch there. So the answer is 3 after you subtract them from each other. So looking at the answers, the answer is B. The weight changes, but the CG is not. No, this answer is A. The CG moves forward approximately 3 inches. That's correct. So let's backtrack what transpired. So upon landing, the front passenger, right? So upon landing, we have this front passenger. Make it a different color. The front passenger. All right. The front passenger who weighs 180 pounds. All right. He departs the plane. All right. So we have the data. He's 180 pounds, right? And he has a momentum of 153 pounds. All right, good. A rear passenger. Now there's a passenger in the rear. Passenger in the rear. He's 204 pounds. What's interesting about him is he moves to the front passenger's position. So he changes positions with the front passenger. So there's a movement of weight. So he was in the prior flight, right? Before the old passenger moved, right? Before the old passenger moved, you had 180 pounds in the front and 180 and 204 in the back. So you had two weights. Then after the front passenger leaves, now there's only one passenger, and the rear passenger comes to the front. I think without drawing a picture, it's hard to convey, but that's what's happening here. So this old equation has both passengers in their designated seats, all right, for the denominator and the numerator. For the numerator, for the denominator of the new situation, right? The old passenger, the one passenger has left. So that affects the denominator. Now, as per the numerator, we're looking to see the changes that's happened, right? That is, the numerator is our moments, the changes of moment that's happening. So we have to add the two changes of moment that the 180, that the front passenger did in total, which is 153. But with the rear passenger, or the second passenger, rear passenger, there's two movements happening. So after we get the difference of that, we add those two numbers. And that's what we have, that's why we have the new numerator. Then to figure out how much change was done, and if it was done appropriately, we have to find the center, the CG of both subtracted, and then we see exactly how much change has occurred, or how much of the center of gravity has actually occurred. It's a little bit of a mess. I didn't draw a picture, but I hope that makes sense. So we're on 66. What effect does a 35-gallon fuel burn have on the weight and balance if the airplane weighed 280 pounds and the momentum over 100 was 2,452 at takeoff? Well, the 35 gallons needs to change first because we're dealing with weight. So we have 35 times 6. So we have 200 and we're dealing with 210 pounds. That's the first thing. So, all right, what effect does a 35-gallon fuel burn have on weight and balance if the airplane weighed, so if the airplane weighed 280 pounds, and then they give us the momentum? Well, what effect does a 35-gallon fuel burn have on the weight? It's going to become lighter. So let's take a look at this. A, B, and C. Weight is reduced by 210 pounds, and the CG is aft on limits. It's behind limits. The CG is unaffected. That's for B and C. The weight is reduced to 2,680 pounds, and the CG moves forward. All right. Well, let's find out first how much the plane weighs now. So the plane did weigh 2,000. Let's see here. 2,890. All right, that's initial. Now we subtract. All right. So looking at A, B, and C, the numbers are right more or less. It is reduced by 10. It is reduced for A to 10. For B, it is reduced by 210. That's correct. And for C, the weight is reduced to, it is presently at 2,680. So it's not as simple as that. So now the point of the question is CG. So let's focus on the CG aspect. So looking at the discussion, the fuel burn on a weight balance is required. Okay, etc., etc. All right. So burning 30, the fuel would reduce by weight by 210, and the moment by 158. So let's figure out the moment. So the moment is for fuel for 158, excuse me, for 210 pounds is 158. So yes, we lost 158 in the momentum. Let's write that over here. So we have the moment for this on our chart? 2,890. Yes, we do. We'll look at it right here. Let me magnify it. So 2,890 is right here. Okay. So look at that in your book. Oops. All right. So 2,890. That's so the limit. The range is 2,354 and 2,452. So let's write these two. So let's see here. So when it comes to writing the moments, we're going to write the maximum. We don't have to deal with the minimum. So the maximum is 2,452. So 2,452. You don't need to work with the minimum when you're working with this problem or any of these type of problems. Just work with the maximum. So 2,452. So that needs to be subtracted from 158. And after we subtract it, we get 2,294 is our new momentum, our mom over 100. Now we have to figure out if we're on limits or off limits, taking a look at this. So we have to look at our chart, 2,680. Let's see if we can find that. All right. Two thousand 2,680 falls between 2,123 and 2,287. So unfortunately, our number goes above that. And because of that, it affects the CG is apt of limits. So that's the answer. The CG is apt of limits. So the answer is A. The weight is reduced by 210, and the CG is apt limits. It's not in, it's beyond. It is beyond it. All right. Okay, so we have two more problems left. All right, 67. Determine if the airplane weight and balance is within limits. All right, we have our weight and the momentum. So let's do everything. We have the front seat, which is at 415. We have the rear seat, which is at 110. We have the fuel, which is at 44 gallons. We're going to change that right now. 44 gallons times 6 equals 264 pounds. Oh, we have auxiliary tanks too. All right, so we're right, fuel T. And then also we have 19 gallons, so we just multiply by times 6. That's 114. And baggage, 32. And the empty weight with oil, which is 2,115. The momentum for that will be 1,554. All right. Now now we have to do, let's see, baggage. Baggage, we don't have that there. All right. So we have to do the multiplying. So 32 32 times the arm here for baggage is 140. We multiply that, we get 4,480. And we have to move the decimal place. So we get 44.8. We just need to write 45. Just round off to the nearest whole number. Next is fuel, 114. Is that an option? No, it's not. So we have 114. And the arm of that is 75. So we have 8,550. Move the decimal place, which will be 80. I think I made a mistake. Let me do that again. So we have 114 is the fuel. I'm not seeing, oh, so I made a mistake. So when it comes to finding the fuel for the tank, you need to use this chart. 114 is given. It's 107. So bear that in mind. That will be 107. Now for the regular fuel, we can use the usable fuel part. That's 264. 264 is given, that's 198. All right, now for the rear seat. Now for the rear seat, we have 110. Oh, we didn't make it. We almost made it. It's not there. So we had to multiply 110 times 121 and then divide 121 or move the decimal place. We have 133, excuse me. So we can just write 133. Next we have 415. So we have 415 for the front seat. Is that an option? No, it's not. So we have to do 415 times 85, which is 35,275. And move the decimal place. And we get 352.7, so we can just round it off to 353. So now we tally, we get 2,390. And here we get 2,950. Now, to the crux of the question. Determine if the airplane weight and balance is within limits. So looking at the options, they want to know exactly how overweight, what overweight are we in? Well, first of all, it's the weight is 2,950 and the max weight is 2,950. So A and B is not the problem there. All right, let's look at our momentum at 2,390. So unfortunately, we're not aft, but we're not. So if you look at it, let's zoom in. We're looking at this number. Well, not that per se, but exactly these numbers. 2,422 and 2,491. We are 2,390. We are below that. We are below that. So we are not. So the answer for this is The weight is within limits, but the CG specifically is out of limits. Okay, we're now on question 68. Which action can adjust the airplane's weight to maximum gross weight and the CG within limits for takeoff? Oh, all right. It says, what action can adjust the airplane's weight to maximum gross weight and the CG within limits? All right, so it's different here. So we're not just dealing with weight, we're dealing with the original weight, the new weight, and the momentum. So, all right. So I'll call this original weight and the new weight. And let's figure this out. So we have front seat, right? The front seat is 425 pounds. And that's great. And that's the old weight and the new weight. Then we have the rear seat. Rear seat is 300. I'll put 300 and 300. Fuel changes though. All right, we have fuel. So fuel is 44 gallons. We'll change that right now. 44 times 6, 264. All right, we'll come back to that. And the empty weight, right? That remains the same, 2015, 2015. All right, so which action can adjust the airplane's weight to maximum gross weight and the CG within limits of takeoff? So we'll get there in a second. Let's go ahead and do our moments. So we know this one, well, start from the bottom up. We know that this was 1554. I don't know what the fuel is. We'll come back to that later. 300. Let's see here for rear seat. Was 300 there? No. So we have 300 times the arm is 121 divided by 100 and 363. 363. All right. Then we have 425 times, this is the front seat, times the arm, which is here at 85 over 100, 361. Now here they're honored up to 362. Fine. So we're at 362. All right, now let's tally. We'll do a different color. So for each one, we'll put, all right, for the old weight, when we tally it, we get 3,004. That is way overweight. The max is what? 2,000 and this, right? So what is that after we're done? Well, after we subtract that, we get 54. We get 54. I'll put 54 here. Oh, you can't see that color. We get 54. So this means the new weight should technically equal this, 2,950. So then what will the fuel be to get that? Well, It would be this, exactly that. So that's what we need to add. So the adjusted fuel then to make this plane worthy is 54. 54 would go there. Now, putting that there, we have to adjust the moments. So 54, and this is the regular fuel here. So is this an option? No, it's not. So we need to multiply 54 times the arm here is 75 equals 4050. Move the decimal place. 41. No, that sounds, oh, I made a mistake. So my mistake is this. So yes, it's 54. Yes, it's 54, but it should be 54. It should be 54 less than this, excuse me. It should be 54 less than 264. It should be 54 less than 264. It needs to be 54 pounds lighter. So 54 pounds lighter than 264 would be 210. That makes more sense. So we have 210. And is that an option, 210? Yes, it is. 158 is the is what it is, 158. Great. So we can tally that up and we get 2,437. Now, reading the question again. So looking at the answers, drained 12 gallons, drained 9 gallons. So basically how many gallons is between this and this? What was the change? All right, well, let's rewrite this. So the gallons for the old weight, right, was 44 gallons. 210, let's see here. Well, I'll write it here. I'll write the math out. 210 pounds, right? We know that they are 6 pounds per gallon. So we just have to divide our 210 over 6. So that is 35. So how many gallons by how many gallons do we need to decrease? Well, it's simply subtract 44 from 35, and that is 9. So the answer for 68 is B, drain 9 gallons of fuel, as indicated here. That ends this section.